take it. Let's wing it. Okay, so we're doing page 4 first. 4 goes in the corner. And today is 327. Okay, so 10.1 is area of plane figures. So what does that mean? Do you guys remember geometric plane when we're on a flat surface? That's what we're talking about. We're not talking about on an airplane in the air. We're talking about flat figures. So anything can be a plane figure. So we're specifically talking about rectangles, parallelograms, like parallelograms. We're talking about triangles, and we're talking about trapezoids and all that stuff. So we're going to start with a parallelogram, okay? Does anyone know the area of a parallelogram? 360? Not even. That's the total number of degrees. Parallelogram. Okay, so draw a parallelogram. You're talking about angles. We're talking about area. So angles don't come into play unless we are missing one of the sides and we have to use trig. So I'm talking about, like, who wants to use trig ever? We've got the height. Remember that the height, hey guys, listen. The height always meets the base, whatever the base is, at a right angle. So we've got base and height. What do you think we're going to do to these two things to get the area? You got to multiply them. Is it just base times height? I'm going to do one of those examples, okay? I'm just showing you the formula for notes. No, they're not notes. Base times height. Base times height. That's the parallelogram formula. Alex, are you on your phone? No? Okay. You look like you were on your phone. Okay. Base times height. Let's go ahead. Look. Can we, like, walk in, please? Not what I just heard. What I just heard was not locked in. But I did. Okay. So which one looks like this picture where we can use the formula? Yeah, number 3. Do we want to do number 3? Okay. So example, look at number 3. Okay. So we're going to go ahead and do number 3 together. It's just base times height. That's it. Parallelogram is the most basic one. It's base times height. Okay, done. So area equals base times height. What's my base? Yep. Label it. What's my height? Very good. So you just do 12.9 times 7.1. And then you get your answer. This goes on page 5, my table of contents. You guys tell me what it is. 91.59. What are my units? It's area, so we multiply 2 lengths. So that means we're multiplying inches by inches. So how many inches do we have? Inches squared. Okay. Ugh. Okay, should we do triangle next? Yes, we're going to do triangle next. We're going to do, hey, here's a spoiler alert. We're going to, yes, 1/2 base times height. Here's a spoiler alert. I'm going to move it down. So a triangle, how we get it, we're going to do like discovery for how we get these. A triangle literally is half. So draw another trapezoid. Go ahead and take half of this trapezoid. So I'm going to use a different color so it's a little bit more obvious. So I'm going to cut this in half to show you that the formula is the same. Because I'm trying to help you discover it. So triangle formula is literally 1/2 base times height, because I just want this little bit. So you use the same formula. Your base is the base. Your height is whatever the height is from the two bases. So from the very vertex. So the area formula is 1/2 base times height, or you can write it as area equals base times height divided by 2. Either one of those is good. Yeah, so we're like basically doing a review. Okay, which one on the paper that you guys picked up should we do? We can do 2. Yeah, let's do 2. We're very sassy today. We're a sassy bunch. Okay, number 2. So I'm going to put number 2 as the example. Me? Okay. Okay, what's your base? What's your height? Yep. I always just do base times height divided by 2. I don't do 1/2, but like you guys told me 1/2 base times height. I think it's because we're so used to saying it a certain way. That's totally fine. Go ahead and do that math for me.
What's that?
Same way as the other one. What did you get?
159.75
Meters squared, because again, area. Okay, let's do trapezoid next. Ready? Okay. Trapezoid. Okay, so for a trapezoid, it doesn't really matter how you draw it. I'm going to draw it kind of wonky like that, where we have the height, and then we have 2 different bases. Because the bases are not the same, you can't use the formulas that we used before. So we got base 1 and base 2. Again, the bases don't matter, but they're the 2 parallel sides. And I know I drew mine kind of wonky. My line is not straight. You know, it's okay. Your lines don't have to be straight. Just know that they're supposed to be, they just aren't. Okay. Here's what we're going to do to figure out the formula. I'm going to make this into a parallelogram. You ready? Okay, so a parallelogram has congruent sides that are opposite, right? So I'm going to take base 2 and I'm going to copy paste it up here. So I'm going to eyeball it using my fingers. I'm going to just mark it down. If only I was ambidextrous. It's like right there. Okay, so there's base 2. And then base 1 is smaller. Very technical skill right here. What? I had too much coffee. My hands are too shaky. It was yummy. Okay. How do we feel? Does it look like a parallelogram now? Yeah. It looks like a parallelogram. So what's our formula? Our formula is half of the parallelogram formula because we only want this bit. We only want this bit. We only want the OD shape. So the point is we do Base 1 plus base 2, because that's the base. This is base 1 plus base 2. Is it not? Okay, hold on to your question. Don't forget it. Remember it. Okay, this base is now base 1 plus base 2 times the height would be the area of this whole thing. Do we want the area of the whole thing? No. So what do? We divide it by 2. Very nice. Okay, cool. So area equals base 1 plus base 2. Yeah, what's your question? Times height, but then divided by 2. Because you mean base 2 plus base 1?
Like, here at the top is base 1, but at the bottom is base 2.
So if we just added it, it would kind of curve into itself and you would create a bunch of trapezoids. So the goal was to get this side equal to this side. So this side is missing base 1, so we add it. Now this side is missing base 2. So you basically duplicated the shape and then flip it so that you get one gigantic trapezoid. Or not, sorry, one gigantic parallelogram. Yeah, so the goal was to discover this formula. It's the parallelogram formula, adding the 2 bases, but then dividing it by 2. Just like the triangle formula is the parallelogram formula divided by 2. Okay, so it's just to discover the formula. Which trapezoid do you want to do? Do you want to do let's do 5. Let's do 5. I know I asked that question, but then I told you which one I wanted to do. There's also trapezoids on the back, just FYI. Is there one that you want to do on the back of? We can do more than one. Let's do 5 first. So number 5. Yeah, on the front. On the front. My bad, because we do restart numbers on the back. Okay. What are my bases? Yeah. Okay, my 2 bases, we're going to add those together. Which one is my height? 16. So the other 2 sides are just to confuse you. So times 16, and then we got to divide it by 2. Go ahead, add them together, add the bases first, then times by 16, then divide by 2. Tell me what you get. I got that too. Okay. We got, trying to think of what other formulas we need. So circles, we got 3 more formulas to do. Circles we already know because we kind of talked about it already. You guys want to go over circle formula? What's up, Hannah? What happened? You good? Did you hurt yourself? Oh, okay. No worries. What's the formula for the circle? Yeah. What's the circumference formula? We talked about it last class, 2 classes ago. That's it. 2 pi r. So you could also use diameter. Circumference equals pi times diameter. There you go. So try number 4. Wake up. Thank you. Try number 4. So we're looking for the area. We don't have the radius. What is the radius?
13.
Okay. Who knows what 13 squared is? Nice. So my answer is 169 pi yards squared, or we can go ahead and multiply that out. Do you want to use the pi button? Okay, 169 times pi. What do you get? 530.9. I ran out of space, so I'm just going to put 9 because it rounds off. But you would round that up to 9.3 if you wanted 2 decimal places. But 0.9 is good. And it's yards squared. Okay, last 2 formulas we're not really going to discover because, can I be honest, it's really hard to discover these formulas. They're kind of tricky, but they use the same formula, which is kind of silly. So I'm going to hopefully remind you, unless you already remember it, what do rhombuses, rhombi, and kites have in common? So think about those 2 shapes. What do a rhombus is a parallelogram with all congruent sides. What do rhombuses and kites have in common? And it has something to do with their diagonals. So think about it. I know it was such a long time ago, so that's why I said I'm going to remind you what the formula is. So rhombus looks like this. Make sure you draw it so that all the sides are equal. And a kite looks like this. Make sure you draw it so that the 2 corresponding sides are equal. And I told you it has something to do with their diagonals, okay? So I'm going to draw in their diagonals because that's what we're going to use. We don't use the sides, we use the diagonals to find the area. Can you tell by looking at the diagonals what's true about them? They both have 4 triangles, but they both have 4 right triangles. That means the diagonals intersect at a right angle. So that's the thing that both kites and rhombuses have in common, is that their diagonals are perpendicular. And all that means is we're going to use the diagonals to find it. I know this is tricky, but it's really the only new formula that we have. All of the other formulas, you said 4th grade, I'm going to go with it. All these formulas you've learned earlier on, like in elementary or in middle school. I don't think you learned the rhombus or kite formula, but it's diagonal 1 times diagonal 2 divided by 2. I have no idea how they get it. I think they take apart the shape and they get it that way. I've never discovered this formula. I've always looked it up. This is, if I forgot a formula, I would have forgotten this one, which I think every year I do double check. I make sure that you're multiplying instead of dividing. Should I double check it now just to be sure? Okay, let's double check. Formula for area. I'm going to do area of a kite. And make sure that it's correct. Yeah. So it's diagonal 1 times diagonal 2. Okay. I'm going to call these A, B, C, D. So that we have that diagonal 1 is AC and diagonal 2 is BD. And honestly, it doesn't matter. Just know that your diagonals intersect at a right angle. Okay, let's go ahead and pick some examples to go over. And I don't think I asked it on the front, so we got to go to the back side. And it's 7, 8, 9, or 10. So let's pick a couple good ones. 10 is an excellent one. How about we do 10, and how about we do, well, those are both kites. How about we do 10, and how about we do 8, the even ones? Or do you want to do 11 and 9? Do you want to do the harder ones? Okay. 8 and 11? Yeah, let's do 8 and 11. Okay. We can mix it up. Okay. So, number 8, what is that shape? Okay. Nope, it's a rhombus. I'm going to put rom for rhombus. Okay, so I see it's a rhombus because of the tick marks. I know it's really hard to see. The ink is kind of faded. I tell you that this part is 3. That means the other side is also 3. So one of the diagonals is what? 3 plus 3. Okay. Then I see the other side, there's an arrow pointing to it, is 5. That means the other side is 5, so diagonal 2 is 10. Beautiful work. So area equals diagonal 1 times diagonal 2 divided by 2. So it's 6 times 10 divided by 2. Do we agree with Felipe? 6 times 10 is 60. Divided by 2 is 30. Feet squared because we're still doing area. That's it. Okay, you can tell I made this problem number 11 back when I was at Leonard because we were the Longhorns. And so if you ever see a reference to that, that means this question is old. It's because we were the Longhorns. Leonard Longhorns. Okay. Yeah. No. Hawks. Yeah, I was a Longhorn and I was a Hawk. Okay. OH and OR are congruent. That means this is a kite. They are both 10. So this is 10 and this is 10. And then SO is 8 and NS is 15. So I can add 8 and 15 and that would get me NO. That would get me one of my diagonals. What's 15 plus 8? Do we agree 23? Okay. So one of my diagonals is 23. I got to figure out the other diagonal. And the fun thing about kites is that one of the diagonals bisects the other. So NO is the one that's cutting this whole figure in half. So HS is going to be the same as SR. So all we got to do is find that. And since it's a right triangle, we can use whose theorem? Pythagorean's theorem. We never get too far away from Pythagoras. Yeah, the cat. Okay. I'm going to call this B. So we got 2 sides. We're missing one side. I just called it B. It could be A. It doesn't matter. Could be X. Ooh, no. Careful. 100 is equal to 10 is C. That sounds like I said Tennessee, but 10 is C, the hypotenuse. So B squared plus 8 squared equals 10. I know. I heard it as soon as I said it. Tennis. Can't say it and not think about it. I heard it. Do we agree? You agree with yourself? I love that for you. Imagine if you don't agree with yourself. Okay. I also got 6. So that means HS is 6. So what is the whole HR? What is the whole length? 12. 6 plus 6 equals 12. So now to find the area, we do 23 times 12 divided by 2. Oh, my work is so messy. Okay, I got 2 people saying it. Do we agree? 138. What are my units? Nope. Centimeters what? Squared. Thank you. Okay, any questions on this? Anyone want to do another one? Okay, I'm going to